Okay, so we already have covered chapter 7, which is substitution reaction, starting with the SN2 reactions followed by SN1 reactions, and we have to understand the rate of reactions between methyl, primary, secondary, and tertiary. And for the SN2 reaction is depend on the bulkiness, the bulky substitutions, no reaction happens, less bulky will complete all the reactions. And for the second one, okay, the SN1 reactions is depend on the stability of carbocations. We can see the tertiary carbocation will stabilize compared to the secondary and also primary carbocation. Okay, so is it clear? Can anybody can hear me? I'm quite curious about this one because okay, so thank you, Ms. Mida. So I already give you some questions, so I will skip a few questions because if there are repetitions or quite similar, so I just want to understand to show you how we can manipulate some information that we have in our what we have learned before. Okay, so the first question is regarding consider the following SN1 reactions. Okay, for the final we are not highlight SN1 reaction, so you have to determine by yourself whether this one is SN1 reaction. So if I don't put SN1 reaction, so I think you understand because the tertiary, but we can have it here. Okay, yeah. Okay, this one is tertiary amines. Okay, tertiary halide, so it will be tertiary carbocation. So and after that, this one is the kind of solvents. Okay, aprotic or aprotic solvent. So you have to determine which one. So how to do it is kind of easy. First, you have to form the carbocation. So what we can do is just put the arrow here. Okay, so and after that, draw the second intermediates. Okay, which is okay for the SN1 reactions. What we will have from carbocation first, and the second one is nucleophilic attack. Okay, this is two words to guide you how you can do the mechanism for SN1 reactions. Wait, somebody in the lobby now, so I have to. Okay, so the second one will be the carbocation that we have here. Okay, so and after that you have water. It's a nucleophile. So the water is a nucleophile attack the electrophile. So nucleophile attack the electrophile. So okay, so it will give you the second products, which is the final products. Okay, H2. Okay, again you have to calculate the charge. Okay, you know, I think I forget what chapter we already discussed about the charge. So this one should be in positive. Okay, and after that, this is it, the products. Okay, make sure you draw correctly whatever is it. Okay, so it will help you a lot. Okay, so for this one, I guess we can give you 2 marks. Okay, so if you get this kind of answer, say, so there will be a 2 marks. Okay, for this one. Okay, the second one, draw the energy diagrams. Okay, this is the instructions. You have to draw energy diagram, and you have to label the excess. Okay, so it's mean all the statement here. Okay, we give you some marks. Okay, starting materials, product, activation energy, and delta H. Okay, and this is very important. Assume that starting materials and the product are equal in energy. So for the SN1 reactions, there will be a two loop, one intermediates. So you have to draw for all information that you have. Okay, so we have just hand sketch, okay, so okay, so first we have to form an axis, okay, energy, okay, so reaction coordinations, okay, so first you will have activation energy and also delta H. They say delta H is equally amount. So what we can do, we can put two types of dash, maybe like this. Okay, second one like this as a guidance, because we are not giving you the values. Okay, first, okay, so there will be like this and also like this. Okay, so this is will be a static material. You should draw the static material. Okay, so this is the reactive intermediates. You should draw the reactive intermediates. Okay, and this is the products. Okay, so don't label like SM, RI, P, no, but you have to draw all the products. Okay, and also make sure you are labeled, because in this one we already asked you to label the activation energy. So the activation energy, the transformations. Okay, so E1. Okay, so this one is E2. Okay, so this one is delta H1. Okay, and this one is delta H2. Okay, and okay, because they said delta H1 and delta H2 is in similar energy, so delta H overall is 0. So from here, if you draw correctly, sorry, some student coming in. So if you draw correctly the starting materials, okay, the intermediates, okay, this is the transition states, okay, you should draw, okay, so and the final product, so you will get a full marks. Normally this one we will give 6 or 10 marks, so depend on the difficulties. So I hope understand. Make sure you draw everything, okay, and this is very important. So let me just something. Okay. Okay, we are waiting. Some student quite late coming, so I think. Okay, next. Okay, I think question number 1 and question number 2 is okay now. Okay, so next. Okay, C, draw the structure of any transit state. In this one, because this one is SN1 reactions. SN1 reactions, okay. SN1 reactions, so they will have 2 transition state, right? Because the in graph they have 2 loops, okay, 1 intermediates. So what you have to do is you have to draw 2 transition state. So make sure you have this kind. Okay, they have 1 broken. Okay, this is dash. Forget dash line. So they will have iodines. So don't forget this one is delta plus and this one is delta minus. So don't forget double dagger like this, okay, sorry, like this. Okay, so this is the first intermediate. The second intermediate, okay, because this bond will be cleaved, the second intermediate will be OH2, okay. This one will delta plus, and this one will delta plus by referring these structures, okay, and also this double. So one intermediate you can get 1 marks. Okay, one intermediate you will get 1 mark. So this one is an first 1 mark. This one is okay. I hope it's clear. Okay, it's easy how to draw the intermediate. So because I think you can learn during your chapter 6 for this one. Make sure you master about this one. Okay. So the second, the fourth one, what is the rate of rate equation for these reactions? So this one is because this one is the SN1 reaction. Okay, so it's only depend of rate, concentration of the starting material alkyl halide. Okay, so it will be I think that's all. Okay, don't forget anything. So okay, so if the question asks what happened if we increase this alkyl halide 2 times, the reaction will be increased 2 times. Okay, or what happened if we increase this water 2 times concentrations, the reaction remains same. Okay, is it okay? Okay, thank you. Anybody who respond? Okay. I hope you are doing this kind of exercise. If you only come and waiting for the answer for me, I don't know. Maybe can or maybe cannot. You understand? Okay. Next questions. We will move to the next questions. Okay, considering the following SN1 reactions, okay, similar questions, but different question actually. What's happened to the reaction rate in each of the following instances? Okay, the first one, the first one, the leaving group is changed from iodine to chlorines. What is the answer? I'm waiting for the checkbox. They have 3 probabilities: increase, decrease, or remain the same. Decrease. Why? E.g., while you, Awate, why? Okay, I will copy the answer from your friends. Okay, decrease. Why? Anybody can answer why? Okay, this is because iodine is better leaving group compared to chlorine. Okay, you can answer like that. Chlorine is poor leaving groups. Okay, yes, E.g., yes, you can answer like that. Okay, congratulations. Okay, the second question, if we change the solvent from water to dimethyl formamide, what's happened to the reactions? Okay, I hope we can have two-way conversations even though we are online. So what's happened to the rate of reactions if we change to dimethyl formamide? Okay, Anis, what's the answer? Nurus, Anis, Nabila? Anybody want to answer this question? Reaction remains same, no change. Okay, what's happened? Okay. Actually, there have 4 effects that we have to consider. The first one, okay, congratulations, it's decreased, Liu. Okay, thanks. So you have to, they have 4 consideration that you have to do whether we want to, when we want to determine the reaction is fast, slow, and something like that. SN1, SN2. So first one, you have to check the alkyl halide. The second one, you have to check, what is that? The nucleophile. The third one is types of halogen groups or leaving groups. The fourth one, also you have to consider the types of solvent, whether it is protic or aprotic solvent. In this case, okay, the reaction will be decreased. Okay. Okay, because why? Because polar protic solvent. Okay, polar. Okay. Because polar protic solvent will, okay, SN1 reaction. So you have to memorize water is polar, EMF is polar,
Polar protic.
polar aprotic. Okay, so this is the answer why. So once you explain about the rate of reactions, so what you have to do is you have to state why, the reason why you choose this kind of answer. Okay, for the first one, okay, the reactions, if we change iodine to chlorine, so the reaction will be decreased because iodine is good leaving groups, or the chlorine is very what your friend's answer is weaker leaving group or poor leaving group compared to the iodine. So the second one, if we change the water to DMF, so the reactions will be decreased because polar aprotic solvents favor SN1 reactions. Okay. The last, the third one, so okay, if we change the alkyl halide from, this one is the tertiary. Okay. Okay, this one is tertiary alkyl halide. So we will change. This is the tertiary alkyl halide, and we change to secondary alkyl halide. So what's rate of reactions? Okay, the rate of reactions will be decreased because the second carbocation, okay, are less stable. Or what we can say is the tertiary carbocation is more stable compared to the secondary carbocations. Okay. Yes, 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 EG, yes, yes. Okay, next, okay, what's happened to the reaction if the concentration of water increased by the factor of 5? Okay, so as I said, to answer this kind of questions, you have to write the equations, read K concentration of alkyl halide. Okay, so we already have this kind of equations. Okay, it's remain same or no change. Okay, remain, okay, same or no change. No change can, okay, okay, but you have to explain why, because the rate of reaction depend on the alkyl halide. Okay, because rate of reaction depend on alkyl halide only. Okay, thank you, Jess. Okay, So next, the last question, the concentration of bold alkyl halide and water increased by factor of 5. Okay, factor of 5. Factor of 5 mathematics. Okay, so the rate will be increased. Okay, increase by a factor of 5. Okay, so you have to copy the answer here because the reaction rate is depend on the alkyl halide. For if they say this is SN2 reactions, 5 times 5 is 25. Okay, I hope it's clear. What's time now? Because I don't want to discuss all the questions, otherwise it will take a lot of time. Okay, so I think you understand about this one. So how you can answer? You have to give the reason why. Okay, you have to give whether the reaction. They have 3 answers only: decrease, increase, remain. Okay, so for this one, for this 3 answer, if you choose, okay, you have to give the reason behind it. Okay, so you can get the full marks for this. Okay, next questions. Maybe I will skip this one because it's quite similar. So because this one, okay, for example, I just give you some clue for this one. Okay, because this one is I just give some clue. The rest you will do by yourself. Okay, so this is the primary alkyl halide. So there will be a SN2 reactions. The rate is depend on the both concentrations. K, don't forget K, alkyl halide times K times nucleophile. Okay, so again, if you see the nucleophile like this, strong nucleophile, usually it's referred as SN2 reactions. And also you have to consider solvent. Okay, so for the energy diagram, it's only one loops. Okay, like this, but you have to assume the reaction is exothermic, so you have to know the delta H overall should be positive or negative. Quite curious. Okay, so I think that's all what we can discuss about this kind of questions. I hope you can do by yourself. Okay, because it's already reached to 9:30, so we will proceed with the another questions. Okay, so this one, okay, these questions you have to determine the mechanism of each reactions, which is, I think I have 1, 2, 3, 4, 6 questions here. Okay, okay, 6 questions here. So you have to determine the reactions here. So make sure you understand, really understands about the SN1, SN2, because after this we will jump to E1, E2, and it's quite tricky because next chapter we will combine between elimination and substitutions, and how we can determine whether this reaction is favor SN1, SN2, E1 or E2. Okay, so it's better for you to master this question first. Okay, if I ask about the protic solvent, so you make sure you understand what is that. Okay, so this is really important. So okay, next question, determine the mechanism of each reactions. Okay, so okay, you have to determine the mechanism. Just state the mechanisms, okay, and you have to draw the products. State the mechanism. If you want to draw, yes, but no marks for that. Okay, but for the safe side, I strongly advise try to do some mechanisms. Maybe if we during the markings, we can give you some maybe markah kesian if the answer is wrong. So first one, okay, first what you have to do, you have to based on the 4 factor 4 factor. Okay, the first one is alkyl halide. The second one is nucleophile. The third one is alkyl halide carbocation. Okay. The fourth one is solvent. Okay, alkyl halide primary, tertiary. This one alkyl halide is group 17. The carbocation is primary, secondary, tertiary methyl. Okay, nucleophile is a strong or weak nucleophile. Okay, so for the solvent, protic or protic solvent. Okay, protic or a protic solvent. Okay. Okay, this is the thing that you have to consider. Okay, the first one. Okay, this is the primary alkyl halide. Okay, we know this is primary alkyl halide. Primary alkyl halide only in substitution subject. Okay, it's only favor SN2 reactions, SN2 only. Okay, and we have acetone here, so just doing the normal one because this is not a chiral center. Because you have you have to going back the definition of chiral center. They have 4 different substitutions. This is the definitions, the simple definition of chiral center. So how we can draw the products? Okay, like this. Okay. So this, don't forget this one. Okay, and next we have this is it. Okay. In my experience, when I try to mark your questions, okay, sometimes this bond is missing, sometimes this bond is missing, sometimes this one is at the front, okay, you just go the straight line. So if I see this one, I will put it wrong, even the answer is correct. So make sure you copy 100% from the questions, the structures, and after that transfer to your answer sheets with the correct orientation. So this is very important. Please highlight about this one. Okay, most of the students lose some marks because of this silly mistake. Okay, for the next questions, okay, we will have this. Okay, we know that this one is the secondary alkyl halide. Okay, this is secondary alkyl halide. So this is different substitutions. As I said, this one is the chiral center, so you have to draw the another photons here. Okay, secondary alkyl halides. If we say secondary alkyl halides, they can be pro for the SN1 or SN2 reaction. So write down SN1 or not O, N. Okay, SN2 reactions. Okay, so the second consideration that you have to check is this kind of nucleophile. This is a strong nucleophile. Nucleophile. Okay, so it's favor. It's also, this one is polar. A protic solvent. Okay, so both of these is favor. You can come up with the conclusions favor SN2. So this is slash. Okay, so it's only favor SN2. So what you have to do, because this one is the in chiral center, so you have to they have been go to the inversion configuration. So what you can draw is like this. Okay, so inversion configurations, change the configurations, because this one happened at the back and at the front. Okay, so there will be this one ish and this one OCH3. Okay, so okay, the rest. Okay. Next questions. Okay, next questions. Next questions, what we can do is, let me see the time now. If I not, I just, okay, still have time. So next question is, this one is tertiary alkyl halide. So you have to analyze any information that you get, okay? So you have, this one is tertiary alkyl halide. So it's only favor SN1 only. Okay, so just see this one, SN1, primary and secondary alkyl halide. So if you know there is a substitutions, you have only jumped into conclusions. So primary SN2, tertiary is SN1, but you have to be focused for the the secondary alkyl halides, because it can be both. Okay, by considering another nucleophile and also the solvents. For this one, okay, so this one, the product will be the mixture actually, because they have the empty orbitals in the form of carbocations. So there will be a mixture. So whatever you can do, you can draw both structures, or you can draw like this. Okay. Okay, you can draw both structures, and also maybe you can draw only the products. Okay, so the first one, you have to make sure the number of carbon is correct. So 1, 2, 3, 4, and 5. This is 1, 2, 3, 4, and 5. This is the correct one. Okay, for the next questions, I'm not sure we have a time or not. So maybe I will take 1 or 2, okay, before we finish. So in this one is the secondary alkyl halide. First, you have to determine this one is the secondary alkyl halides. So secondary alkyl halide is favor SN1 and SN2 reactions. And after that, we have to consider also this is a weak nucleophile. Okay, weak nucleophile. And this one only favor SN1 reactions. So SN2 doesn't involve in these reactions. So the product will be both products, okay, both products, and on its alpha or beta position. So I will draw the both products. So 1, 2, 5. First, you have to draw like this. O, C, O2C, CCH3. Okay, the second one will be, sorry, it's quite messy, but I don't have any space now. So okay, O2CCH3. Okay, there will be 2 products. Okay. For me, in my opinion, it's better for you to draw both products. It will reflect that you understand the question, what the question is. Okay. We still have time. Okay, maybe one more question. The last one you have to answer by yourself. Okay. So in these questions, okay, for example, this one is the we just for the I think it's better to draw both. Okay. Okay. Okay, EG. Yes, yes. Just write plus it's mean tambah. It's mean the both compound is formed in this one with the mixture 1-to-1 ratio. Okay. So for this one, the last one, we discussed the last one, and after that we move to the next questions. Okay. So the last one we have to determine this one is the secondary alkyl halix. Okay. Secondary alkyl halix. Okay, my drawing pad is getting better now. Okay, secondary alkyl halix. So we have to make some notes. SN1 and SN2. And after that, this one is a strong nucleophile. Okay, strong. Why? We just arrived to class. Daniel, you just arrived into the class. It's quite late now. And after that, strong nucleophile. And also a solvent. Okay, solvent. It's polar. Polar. Solvent. Okay. Polar protic solvent. So this one is SN2 favor. Okay, both of solvent and also nucleophile favor SN2 reactions. Okay, so because this is SN2 reactions, SN1 doesn't involve, so the product will be, sorry, I'm withdraw here. I don't have enough space. So the product will be 5-member ring, not 6-member ring. So be careful. So this one will be inversion configurations. Okay. So there will be OCH, 2CH, number 3. Okay. And this one will be, don't forget to draw with correct corrections. Okay. I hope it's clear. Okay. The last question, I leave it to you. Okay. So you can do by yourself. Don't worry too much. Okay. So we will go for the next last questions. Okay. Draw the step mechanism for this reaction. So this is the formation of nicotine. So what you can do is, okay, you analysis one by one. Okay, so this one is the secondary alkyl halix. Okay, this is the secondary alkyl halix. Okay, this is the nucleophile, which is a strong nucleophile. So it should be 2Na plus. Okay, so CO3 2 minus. Okay, so okay, this is a nucleophile. So if we break up this structure, so it's become H. Okay. So this nucleophile will attack and will extract the proton here. So okay, extract only the proton. So give back the pair of electron to the end. Okay, this is what happened. So the second one, what will happen? So I will draw again the structures. It will take time. One, two, three, four. And with pair of electron coming from this bond. Okay. Okay. So they will have a H here. And this one will be H3. Okay. So what's happened? This is intercyclization reaction. So this is a pair of electron. So they will have, actually they will attack at the back. So okay, they will give it back a pair of electron here to bromine. So there will be a second structures. Okay. In this case, they are already, because nitrogen can make only 3 bonds. If they have 4 bonds, okay, you have to put plus, or you have to calculate the charge again. Okay, this one is positive, and this one is proton, this one is CH3. Again, we still have this kind of anions. So CO2, CO3, 2 minus. Okay, so we'll extract the proton here. And this one give back to the nitrogens. And finally, it will give the final product. Okay, for this one, what I can say, we will give around 4 marks. Okay, 1 marks for the starting. Okay, this is 1 mark. This is the second mark, third marks. And make sure you draw the final product, which is another 3 marks for you. Okay, if you don't draw the final products, so it's mean you just get only 1 marks. Okay, if the reaction is strong also, you only get 0 marks. Okay, okay, next. Oh, okay, I think that's all for today. As a conclusions for today class, so what I can say is stop.